Hello and welcome to this Python tutorial. Alright, so now that our ANN is compiled, it's time for the exciting step, which is to fit the ANN to the training set. Because you probably noticed that so far we've only built the ANN without making the connection to the training set. And so of course now we need to make this connection. And to make this connection, we're going to use the fit method that will fit our ANN to the training set. Alright, so let's do it. We're going to take, as usual, our object, classifier, then dot, because we're going to use the fit method. And then, of course, here we take the fit method. Here we go. That's the one. Parenthesis to add the arguments. And so as for all the other models we've built in this course, well, the first argument is the data set on which we want to train our classifier. That is our training set. And as in the classification part, this training set is separated in two arguments. First, xtrain, that is the matrix of features containing the observations of the training set, and then ytrain, that contains the actual outcomes of the dependent variable for all the observations in our training set. Alright, so let's first input these two arguments. So xtrain first, and then ytrain. So far it's exactly like in the classification part when we use the fit method, but now things are going to be new because we will add two additional arguments. And if we go back to the stochastic gradient descent slide, you might guess what these two arguments are. As you can see in steps 6 and 7 of the stochastic gradient descent algorithm, well, we see that we can choose to update the weights either after each observation passing through the ANN or after a batch of observations. So as you might guess, this first additional argument is going to be the batch size. And the batch size is the number of observations after which you want to update the weights. Alright, and now what is going to be the second additional argument? Well, to find it, we need to look at step 7, because indeed in step 7 there is this notion of epoch, and an epoch is basically around when the whole training set passed through the ANN, and in reality training the ANN consists of applying steps 1 to 6 over many epochs. So the second additional argument that we're going to input here is going to be the number of epoch. Alright, so actually we can check it out. I'm going to press Command I here to get some informations of this fit function, and as you can see here, well, first we input correctly the first two arguments, which are the matrix of features and the dependent variable vector, and then we have these two additional arguments, the batch size and the number of epoch. So here we can see 32 and 10. These are not the numbers that we're going to choose. Again, this is where your deep learning artist soul comes into play, because again, there is no rule of thumb, and we need to experiment to find some optimal choice for this batch size here and this number of epochs. So right now we're not going to experiment. We will go with some fixed choice of batch size and number of epochs, and we will choose a batch size of 10 and a number of epochs of 100 so that we can see the algorithm in action and so that we can see the accuracy improving over the rounds, that is, over the different epochs. Alright, so let's do it. Let's add these two additional arguments. So first is batch size. So we say we wanted 10, and then NB epoch equals 100. Perfect. So now, time for the show. We are going to see the stochastic gradient descent in action, and we're going to see how the accuracy is improving over the different rounds. So let's not wait anymore, and let's start the show. I'm going to select this line and execute. Alright, and now the action takes place. We can see the different epochs going on. So we started with a 79% accuracy, then 82% accuracy in the second epoch. Alright, so it's going pretty fast. We're almost getting to 25% of the total number of epochs. So which accuracy have we reached? Well, here we can see that after epoch number 24, we reached an accuracy of 0.8486, almost 85%. Okay, epoch number 37 out of 100, accuracy reached 85%. We can also see the information about the loss function. Alright, and we've just passed halfway, and we can see here for epoch number 54 an accuracy of 85%. I think we're going to converge into a 86% accuracy. That would be pretty good. Epoch number 70, here we go, 86.27%. Yes, definitely, it's converging. Still 86% for epoch number 81. Alright, we're getting close to the end. Epoch number 90, 90 out of 100, still 86%. And eventually, our model is ready. And I think we reached an accuracy of 86%. Yes, definitely. Here we can see 86.50%. That was expected. And that's how the stochastic gradient descent algorithm performed on this training set here. So great, very exciting. This is actually the first time we see something like that, because so far all our models executed in 1 second, even less than 1 second. So here I'm very happy to introduce you to this new kind of machine learning model, the artificial neural network. Great, so I hope you liked it. And now time for the last step, which will be to predict the test set results. Well, we already know what we expect in terms of accuracy. We expect an accuracy around 86%. So we'll check it out. It's going to be very easy actually, because you know everything is already well prepared thanks to our classification template. So we won't need to change anything here in this line to get the predicted probabilities that the customers of the test set leave the bank. And same for the confusion matrix here, everything is already well prepared. So we'll do these last 2 steps in the next and final tutorial, and until then, enjoy deep learning!